Coming to the next one, variance. When we say variance, the quantity used to measure the dispersion is called as variance. Now, how do we calculate variance? The variance is given by sigma square, or we write as variance of x, where x is our random value. The expected value of x minus e of x whole square will give us variance. Now, this can be just open in the form of a minus b whole square, that is a square minus 2ab plus b square. So I'm just opening this, so I'll be getting as expected value of x square minus 2x e of x plus ex of whole square. Now I'm just separating each of them as a product, individual product. So expected value of x square minus 2 minus expected value of 2x expected value of x over here plus x plus expected value of x whole square. Okay, now again over here, so this is same e of x square is same e of x square minus this 2 is a constant term, so I'm taking it outside, the expected value of x into expected value of x plus expected value of x whole square. Now this is same as it is, that is expected value of x square minus 2, these two terms will multiply and fetch us what, 2 into e of x whole square plus e of x whole square. Now when we subtract this, we'll be getting as e of x whole square minus e of x, this is e of x square minus e of x whole square. Now we already know that e of x is nothing but it is can be written as mean. So I can write this as if x is a random variable, the variance is given as sigma square is equal to e of x minus e of x whole square. Now this e of x can also be written as mean, so I can write as e of x minus m whole square, where e of x is nothing but m, denoted as m. Now for the case over here also, how we have written expected value for discrete function as well as for continuous, over here for the variance also we'll be writing for discrete as well as for continuous. For discrete, it is written as sigma square is equal to summation xi minus m square into p of xi, where where summation start from I equal to 1 to n, where I take all the values from 1 2 3 4 till the nth value. Okay, now this is for the case of discrete. Similarly, for the case of continuous, the same thing can be written, instead of summation it will change as integration. So sigma x square is equal to integral over the limit minus infinity to plus infinity. Over here we have xi minus m. Okay, over here we have x minus m whole square. Over here you have probability distribution function p of xi. Over here we have probability density function fx of x into dx. Got it? Okay, now similarly how we have written the properties. How we have the properties for the case of mathematical expectation, we have the properties for the variance as well. They are simple properties. The first one says that we can just write var or we can just write v. So variance of a into x. Now over here variance of a into x is nothing but a is a constant term, so this is written as, this property gives the value as a square into v of x. Okay, now variance of a is nothing but it is equal to 0. Over here we are not proving anything, we're just writing the end properties. How we got this, as you might get a doubt, v of a of x is there, over here a square of v of x. When we solve in detail, we'll be getting this. We are just writing the end formula, or we are writing the end properties of it, or end results of it. Okay, now next is the third one says that variance of a plus x is nothing but variance of a plus 1 square into variance of x, that will give us variance of x. Why? This variance of a is nothing but it is a constant and it is 0, so n will be getting as v of x or variance of x. Similarly for this also, variance of a minus x is equal to variance of a, we are separating, plus this minus term we are taking as square, that is a square, or the constant value, not a square, the constant value. Over here minus is there and nothing means 1 square into v of x, so we'll be getting as variance of x. Now in this thing, what we can see, or we can say as, whenever you have variance of a plus x is equal to variance of a minus x is nothing but variance of x. How we have studied in the case of expectation, where we have function of a plus x is equal to function of a minus x, right? Over here also it is similar to that. To make it a little bit concise and to come to a small conclusion in terms of the two differences, we have just listed shortly the few properties of each of them in a tabulated form. Okay, the expected value or means of x can be written in terms of this one. What is this? In terms of continuous function, e of x is equal to integration from minus infinity to plus infinity t x of x into t into dt. Okay, with that of discrete also it is over here. Three of the properties we have mentioned. One is with respect to constant, one is with respect to constant and a variable, one is with respect to constant plus a variable plus constant. Okay, even for the variance of x is given as variance of x is equal to sigma x square. We can write x over here, or even if we don't write, no issues. Sigma square is equal to e of x minus x square, expected value of x minus e of x whole square. The standard deviation of x can be written as standard of x is equal to sigma, which is under root of variance of x. Okay, over here we have sigma square. When we remove this square, we will be getting under root of it. The third property says that variance of a constant term c is 0, whereas over here c, the expected value of a constant is a constant, but over here the variance of a constant term is 0. The variance of a constant term and a variable will fetch us c square, that means constant square. Over here you see it, the expected value of constant into a random variable will fetch us the constant term, not the square. Okay, constant term, right? Variance of x plus c is equal to variance of x. This is the basic differences for the case of expected value or and variance.